The Rodent touchscreen AutoShaping task assesses Pavlovian approach to learning. It compares responses to a stimulus associated with a reward to one that is not associated with that reward. The task involves several neural systems, as shown here. The clinical areas that can be assessed with this task include schizophrenia and Huntington's disease. The optimal chambers for the task include a smooth-sided trapezoid wall to limit distractions within the chamber and keep the rodent focused on the task. A highly sensitive touchscreen capable of reliably detecting a mouse nose poke, even if the mouse does not press its nose up against the screen. A reward trough with light and nose poke detection that can be placed either at the rear of the chamber, as shown here, or in front of the touchscreen. The AutoShaping task requires the reward trough to be placed in front of the screen. A laser-cut floor, and IR ambulatory beams to tell when the rodent is at the back or front of the chamber. When the reward trough is in the front of the screen, the IR beam is split to show which side of the screen is approached. The training procedure for the AutoShaping task is very simple. After exposing the rodents to handling and food depriving them to 85 to 90% of their free weight, they just need habituating to the chamber before starting the task. Masks are placed in front of the touchscreen to form nose poke areas for responding to the task. The AutoShaping mask has two windows either side of the screen and also either side of the reward trough. I will describe here the mouse task, but the rat task works in exactly the same way. As mentioned before, the reward trough is placed in front of the screen, dividing the accessible screen area into two. After a variable interval, usually 10 to 40 seconds, one side of the screen is lit, just as long as the mouse is breaking the beam at the back of the chamber. If the mouse is not at the back of the chamber at this time, then after the variable interval, as soon as the mouse breaks the beam at the back of the chamber, then the screen will be lit. This ensures that the mouse can see both sides of the screen when the screen is lit up. Trials are set in pairs. Which side of the screen is lit in the first of the pair is chosen randomly. Either side will be lit for typically 10 seconds. One side of the screen is designated CS+, and when this is lit, it will be followed with a reward. Once the mouse has learned to associate the CS+ with the reward, they will tend to approach that side of the screen. Approach to the screen is detected by the IR beams on either side of the trough. Touches to the screen will also be detected. After the CS+ is lit, the reward area is illuminated, and reward, usually strawberry milkshake, will be delivered. This is independent of what the mouse does. Once the reward is taken, the reward trough light extinguishes. The variable interval will begin again. After the variable interval finishes, when the mouse breaks the back beam, the next pair of the trials will begin. The second trial in the pair starts by lighting the other side of the screen. The screen will light again for typically 10 seconds. If the side of the screen that's been lit has been designated the CS- side, then as soon as this is finished being lit, the variable interval will start right away. Here we see the mouse responding to the CS+ stimulus and taking the reward. When the CS- side is lit, the mouse shows no preference for a side.